Hi everyone, my name is Mohammad Maaz. Without any further delay, let's move on to the third and the final challenge of our workshop. That is about multilingual, multimodal video reasoning challenge. So let me give you a brief introduction about the challenge. The idea is to measure how well video MLM perform in multilingual setting and also how well they can handle the different cultural specific question and answers in cultural specific videos. So these are the some of the like overview of the challenge. So the challenge, the data set that we proposed has like almost 14 diverse languages. It included 15 real world domains, like for example, festivals, food, landmarks, etc. And when we like measure different video MLMs on our proposed data set, we found that the video MLMs struggle to perform well on low resource languages, for example, Urdu, Bengali, Arabic, etc. Moving into the detailed statistics of the challenge dataset. So the challenge datasets were divided into the two subsets. The first one is the validation set. The validation sets contains almost 2,620 QA pairs in 354 videos. And then we have another track that we call the test track, and the test set contains around over 5,405 QA pairs around in 525 videos. In order to diversify our dataset, we included both types of questions. We had like MCQs as well as open-ended question answers included in our dataset. Also, like we also included like for all almost the languages, the cultural specific videos and like question answer pair that were curated from the native speakers and verified by the native speakers. I'll show the some of the dataset examples. For example, in this video, you can see like the first video is actually representing the Arabic culture. In the second video, you can see it's like these are the videos from the different cultures. So when I mean the culture specific videos, so we actually curate the internet and collected the culture specific videos and then asked the native speakers to create question answers about that, and this is how the culture specific part of the dataset is constructed. Well, moving on, we got almost like 14 total summation in our challenge. And the provided baseline that we have provided was like almost 56.1% accurate on a combined MCQs and open-ended question answers. And the winner of this challenge is the team AI Dreamers, who achieve an amazing results of 80.5% overall, combining both MCQs and open-ended accuracy. So here is a certificate. I would like to request Dr. Sontran to please come on the stage so that we can distribute the certificates. Any representative from Team AI Dreamers?
Congratulations. Yeah, thank you.
Congratulations. You did a good job. Thank you. I guess so. Just a quick question. Are you the one who is presenting? Yeah, okay. Yeah, please, please. Let's move on to the presentation. Let's hear from the AI dreamers how they actually solved this issue.
Good afternoon. My name is Bojang Li, and today I will introduce our team's solution to the multilingual video reasoning challenge. Overall, our solution is visualized as such pipeline, Given the input video and the corresponding query, our two-stage verification system would first process the input question, extract the key properties, including the language type and the task type, and then we will perform the question answering. And finally, the obtained QA pairs will be checked according to the video's information. If all model-generated answers pass the verification, we obtain the final output. And now let's take a look into the data processing step in the entire pipeline. For each question entry, it has the format as shown by the screenshots on the left. The chain of thought prompt template is first selected according to the question's category. Then its language name will be inserted into the prompt, reminding the model to infer and reason about video question with the consideration of corresponding linguistic and cultural background. And the video will pass to the video MLM with 1 FPS, providing enough amount of information density for the problem comprehension. And after the data pre-processing, we gather the model's crest and first detect invalid answers, such as the answers to open-ended question that is either too long or too short, and the invalid choices for the multi-choice questions. And each answer produced in the second step will be verified by the same MLM combined with the same video input to ensure that the comprehension is correct. We will also check the output language of open-ended question answer to ensure they adhere to the question's language types. If the verifier at the second stage does not agree with the answers in the first stage, or the answer has format or language problems, the problem will be reprocessed until it passed the verification. So performance-wise, we achieved the first place with over 80% average accuracy on evaluation set. And specifically, our accuracy on the multi-choice question reaches over 87%. And for the future work, one focus could be applying extra language augmented data for model training or boosting models' inherent understanding for multilingual scenarios through RL with challenging training data. And we could also integrate RIG-based pipeline to boost the models with a large offline knowledge base containing domain knowledge for specific cultural language. And finally, we could also equip the MLM with the web search tools to enable the test time agentic problem solving ability through calling online tools and verifying the answer through referring to the online knowledge. So that's it. Any questions? Yeah, please. You can use the mic.
How did you come up with the chain of thought according to the question? Like, how did you do the mathematical chain of thought for each given question?
The chain of thought, I think, is like we first extract the necessary component from the input and just directly like stack them together to construct the chain of thought. Pardon, I'm a little confused. Like,
So you identify the question type.
yeah, like the question type is limited in this challenge, so we use the prompt that include the like the search space. Yeah. Thank you.